Dobar dan svima, and hello everybody who is watching us on the stream. Welcome to our second workshop. With us we have Luka Aničin. Welcome, Luka, and thank you for joining us on the Regional Scrum Gathering Belgrade 2021. I'm really sad that we couldn't meet in person due to the situation, but let's make the most out of this online event. So far so good, and let's see how it will go on. I wish everybody a warm welcome, and I hope that you will have a nice time with us. Luka will have his workshop, show us some really interesting things. So I really invite everybody who is watching us on stream to join us. Don't be shy. Join us on the Zoom link. The Zoom link is in the description of the lecture. So basically you should go to Match About. On the bottom right corner you have more, 3 dots and more, then go to Agenda, and there you will find this workshop, and you will have the link to join us here on the Zoom. If not, follow us through the Match About, through streaming, and listen what Luka has to say. So Luka, the stage is yours, and have a nice time.
Thank you for a great introduction. So hello everyone from the Zoom call, and to demonstrate like their brand sentiment or sentiment recognition in the natural language processing. The whole workshop will be conducted in Python. So if you don't know Python, I'll try to explain like basic things and how everything works. And I will share the link so you can follow along with the code and experiment on your own side. The whole lecture will be inside the Google Colab. So if you don't know what a Google Colab is, it's an internet environment where you don't have to install anything. If you have Google account, Gmail, you can go there and I see a couple of more people joined after I pasted the link, so let me paste it again. You can go there and basically execute the code. So let me share the screen, and we can start. Oh, and yeah, of course, if you have any questions during my presentation, please interrupt me, and we can discuss. We can discuss that at the moment. If I feel that I'll answer the question later on in the talk in the workshop, I'll explain that during the answer. Cool. So can everybody see my screen? I don't know. Did somebody just say yes or something like that?
We can see it.
Cool, nice, thank you. So this link that you can see here is something different that I shared with you, because here a few code is missing. So I will code along while I'm speaking. So there will be some code along, so it's not fully just speaking, but coding as well. The goal of today's session, as I said, is to create a sentiment recognition using machine learning. And the first, we need to answer what is sentiment recognition. So the sentiment is basically where we decide whether a certain sentence or a text provided to our model is positive or negative. So if you have a comments for movies, for example, then you would basically say, okay, this is the worst movie ever. Obviously, that is a negative sentiment, and that provides some information to us to judge whether or not to watch that movie ever in the future. And that goes for books, for companies. So you can go, and I know some marketing agencies today go manually through tweets for a certain brand, let's say Coca-Cola, and then they read what user had to say about their product, and then they are marking, okay, this is a negative or a positive sentiment. With the machine learning, you can do that automatically, and the whole code that we are going to write today is in Python. So I don't know if you had experience with the Python. Don't worry if you haven't. Okay, cool. So before we jump, we need to download the data set. So if you want to follow along, I do suggest going to this link here. It's going to move you to Kaggle if you haven't used Kaggle before. It's a website where you have many data sets for probably anything that you want to experiment with, and it's all open sourced. So for this Twitter sentiment analysis, you have a data set where you can download simply 5 megabytes, nothing special, and you need to upload that to your Google Column link that I pasted. So how to do that? You can go and click to Files, and then let me just find the file, and I'll share my screen again. I don't know because of the documents. Okay, so let me find the file. Yeah, cool. Okay. So let me share my screen again, and let's continue. Okay, cool. So I just drag and dropped my train.csv file here into this folder. You can simply do that, and it's going to upload the file to your Google Column. Just one note, you will have some notification pop up if you're using for the first time, saying that all files uploaded will be deleted, because Google provide us with this environment for a couple of hours only for free. So later on, all files uploaded for security's sake and for speed of their servers, they will delete this file later on. But for our use case, it's fine. Cool. So if you've done that or just following along, that's fine. You need to have only train.csv file in this folder. So the first thing that we need to do is import some libraries. One really important and powerful thing that Python provides us with is a set of libraries that we can use for almost anything that we really need to do. And that is really the core power of Python. The community that creates these libraries for us, so we don't have to code everything from scratch. And we have some, okay. This set to public. Let me check again. Okay, so anybody with this link, I'll send you again. So you can make a copy to your account. That's something that Google needs you to do if you want to execute this code that I sent. And also, if you don't see the code, sometimes Google needs you to give like permission to your Gmail or something like that. And that's basically why you don't have the access. It's simple steps, like a few clicks, and you will have the access. Please write me if you didn't manage to do that, and then I can try something else. Cool. So let's continue. So we need to import a set of libraries. The first one that I've imported is pandas, and for those who never use Python, obviously you don't know what pandas is, but basically pandas is a library that helps us to work with CSV files or comma-separated value files, or some like Excel files, and also SQL files. So you can import almost anything, any source of data to these pandas, and it will help you like sort files, search those files, organize, merge, and many other things. The sklearn or scikit-learn is a very famous library that allows us to use machine learning algorithms in just one line of code. So if you're not a machine learning engineer, if you don't know what actually some algorithm does, with sklearn, you can do that in a one line of code. That produces some risks and some maintainability issues later on. But for basic prototype sklearn is amazing. Here, if you see that, for example, sklearn.featureextractor.text and so on, you are importing specific functionality from that library. So if you haven't done that before, this is how you specifically import certain things that we are going to use. And yeah, that's basically it. For now, I won't explain any of this. We are going to explain that when we reach the point of usage. So to execute the cell, you can simply click on let's say, play button here, or you can shift enter when your cursor inside of a specific cell, and then you will execute that cell. So now that we've done that, we need to import the data set that we uploaded a few minutes ago, this train.csv. So to do that, I'll define data as a variable, and then we need to call pd, which is shorter for pandas, read CSV, simple function, very intuitive, and just provide the name of the file if you have it in your environment, like this. And that's it. Your data is loaded for you, and you can keep working for that. So let's just see first 5 rows. So data, which is this one, .head, allows us to read first 5 rows of our CSV file. And here you can see that this file contains 3 columns. And if you work with SQL or databases, this is similar to that. So you can work basic querying with this data. If you want to find, let's say, where the label is equal to 1 or 0, for example, or where the ID is equal to 3 or so on. So this is allowed by pandas for us. So here you can see that we have label, and a label basically stands for whether or not certain tweet, in this case, is a positive or a negative sentiment. So in this case, 0 represents positive sentiment, and 1 represents a negative one. And you can see here that we have tweets. And yeah, so that's basically what we have here. So that's something that we need to work. And when you're working with text, you generally need to make a lot of changes to the original text so you can work with mathematical functions, which is machine learning. So we as a humans, we have amazing opportunity to just read certain tweet and then immediately know whether or not is a positive or what it actually means for computers. We all work with, when we're working with programming and computers, we all work with numbers. So we'll take some certain steps and techniques to change these things to numbers. And that's something that is actually hard part of this whole workshop, where we need to perform certain steps to have a workable text for our machine learning algorithm. Now that we know that, the next step for us is to create training and test or train test validation parts of our data set. So this is one of the very important parts of machine learning. If you haven't worked with machine learning or read some technical code of machine learning before, that's completely fine. But wherever you go and try to train a certain algorithm, you will have this step done in more or less complicated way, depending on the task, depending on your data, and many other things. So why do we need to do this? The first thing, when you download or when you have the data, like let's create an additional code cell and then data.shape. This will provide like what is the shape of our data. 3 is number of columns, as you can see, 3. And this is how many rows we have. We have about 32,000 rows. And that's the whole data set that we currently have like let's say collected in our marketing agency or our company or our investment like VC, if you want to judge a certain startup, for example. So if we train the algorithm on the whole data set, and we use all 32,000, our algorithm might be really good at recognizing examples from the data set. So if you get a new tweet, for example, that the algorithm never saw before, or the wording or choice of words that never been in the data set, our algorithm will perform poorly. And you need to test that before putting a certain algorithm in production, because you can definitely screw up a lot of things when you put the algorithm that you haven't thought about the results in the advance. To not to overcome, but to prevent putting the algorithm in production that is not tested on unseen data, we are doing these splits. So we are using our original data set and then splitting into two different parts. One, we're only used for training. So we are optimizing our algorithms, whatever algorithm we decide to use, on this orange part of the data set. And then when we have the trained algorithm, we are going to put it on the test set and to see how it well performs on unseen data, or the data set that we never saw before. And this blue part is something that is expected to be generated by the end user when we put our machine learning algorithm in the future. The similar thing can happen here. You will see some examples where you have a training set, validation set, where you validate your model on the unseen data, but the test set is locked in a safe and never seen before, until you reach the point and say, okay, my algorithm works well on the validation set, which is still unseen data, and then you test it on the test set. It's more complicated way, but it will definitely provide one additional step of validity to your model and accuracy to your model. Cool. So this sounds really complicated. How are we supposed to split the whole data into like train, test, or even validation set? sklearn again thought about this and provides with a simple function called simply train test split. And in a single line of code, we'll split our data set into two different parts, one for training and one for testing part. So in this cell here, if you are following along with the code that was given by the link, you will have 3 lines. So let's implement those lines. So first we need tweets. We need to extract tweets from our column, which is called simply tweet. So to do that, you can go and define our data, which stands for the whole data set. And then Google already offers us with the column names, ID, label, and tweet. So we'll just choose tweet. And later on, because it will, if you provide only this code, it will not only provide us with tweet column, but ID column as well, because it will use that ID column so we can reference certain tweets from that data set. But we want only tweets. So to do that, you can simply add dot values and we'll return only pure tweets and strings. Then we want labels. And again, it's data of labels, or label, sorry, dot values. With this, you will have 2 different variables. One will contain only tweets and the second one labels. If you read some articles about machine learning, most often you will read targets and not labels, but it is interchangeable usage of that term. So if you use to call these targets, that's completely true and correct. So depending on what school did you go to or what article did you read, so it's the same thing. And Lastly, we'll call this function. So the function returns 4 different things: x train, x test, y train, and y test. That is equal to train test split. And I'll explain this in a second. And then we'll provide our tweets, our labels, and then it is optional argument, but highly recommended. It's test size, and you define it by 0 dot, for example, 2. And this means that 20% of our data will be used for testing size. So this X and Y is used for from like conventional terminology that is used in machine learning. So X means features, or in this case, tweets, and Y means targets or labels. So because each machine learning function is actually just a function, so it is for mathematics, Y equals to something else, and X is the input to that function. That's basically how we decided to name X for our features and Y for targets. If you execute this this code cell, you will have, let's say, X train. X train is 25,569 in the size. So that means that we successfully split our data. And let's show first 10. As you can see, we have first 10 tweets. You have waiting for the first media comment to downplay and so on. One interesting thing, and that I haven't mentioned before, is that you can see that we don't have all zeros or all ones. We have mixed, so mixed zeros and ones together, and that's something that our train test split function does for us. So it shuffles the data for us to make our algorithm more robust. And if you execute this cell again, these values might change because the train test split will split the data set in a different way, and then you will have different results as well. So if you have the accuracy or the end results a bit different from mine, this is the reason why that is happening. Cool. So I mentioned before that we need to work with text. We need to make it readable by mathematical formulas, or in this case, machine learning algorithms. And we need to convert pure strings or pure text to basic numbers. And there are many, many techniques from NLP that people are learning about for months, even years sometimes, depending on how deep you are in the field. But this Spacey library, which, sorry for these big letters, it's just a picture like that, allows us to do all that pre-processing in just a couple of lines of code. So this Spacey is a fantastic library if you want to work with text. It's mostly optimized for English. There's some support for German, I think, and Spanish language. I don't know for Serbian. But yeah, it allows you to pre-process the text and prepare it for your tasks. So again, we need to import a few things. First off, we need to import string, which is native Python library called string because it allows us to work with strings, Spacey. And here we'll import stop words and English because it supports a set of languages. For us, we are supporting right now English only. So we'll import the English and stop words. I explain what the stop words are in like about 4 minutes from now. Cool. So first thing that we need to define is punctuation. So we'll define a variable called punctuation, and that is equal to string. Oh, I need to execute this code cell dot punctuation. So this will allow us to detect all punctuation used in our tweets and remove them. And now it's good time to mention that when you're using or doing the sentiment analysis on your text, most things you don't really need. So for example, if a sentence is saying, okay, I love this chocolate with exclamation mark, we can agree that that person really loves that chocolate. But if it is ending with just a dot, it's still like a positive sentiment, but it's like in an intensity is lower. If you're just detecting if a sentiment is positive or negative, which we are doing right now, it doesn't change by having that exclamation mark at the end. We do agree that it's more positive than with a dot only, but we don't need that right now. So we are going to remove this, all of these symbols from our text because we don't need it. And you can see that there's many mentions or tagging in the tweets in general, so we don't need that as well. Because if I'm just tagging to Ivan, for example, at Ivan, I love this chocolate, it doesn't change the fact that I love that chocolate, just additional word that we added to our model. And then we need to remove one more thing, which is called stop words. So in English, you have, or any language in that matter, you have words that are really common and they don't really provide any value to our analysis of text. Those are, for example, I, those are, actually, let's just write the code and then see together. Okay, and then we'll need to load English. So spacey dot load and just simple en for English. And then we'll define stop words. And that is equal to our stop word here. This code is a bit different from the code that you're seeing right now. If you want to follow the exact pattern, it would be spacey dot lang dot en dot stop words dot stop words. So this, or only without this, is the same. And then we'll define English parser, which is only English. So if you execute this code cell, you'll define all of this. And let's see what are the stop words here. Oh, okay. Okay, cool. So I tried something that Python was not agreeing on, so no worries on that. But you can see that, like, for example, I'll, M, R, E, S, and so on, about, again, along, M. So basically all those are providing some values for it, but for the sentiment analysis, not really. So if you're, for example, creating a chatbot or creating a certain, let's say, translation model, something like that, from Serbian to English or vice versa, you will need all of these words to be present because you are definitely wanting to translate directly or in the matter, in the context of the language itself. For us, for example, if I say, I love the car when I buy it, or I'll take a good, I don't know, care of my new car, and I love it. So this I'll does not actually provide any value to us. Or I've watched this movie and I've loved it, or I hated it. This doesn't matter if I watched it today or watched it a few decades ago or whatever. The key word that will influence our model here is hate. And you can actually help your model focus on only words that have the high meaning for our sentiment. So that is, for example, love, hate, disgusting, yeah, and many more that actually have the sentiment value. For about, it doesn't actually have any value to it. And yeah, so after that, there are, and you can basically, before that, you can see that there are many okay, there are many words, stop words that we are going to delete. So about 300 and not about, but exactly 326 that we are going to remove, plus our stop punctuation that we'll definitely remove as well. So after you've done that, we need to define something called sentence tokenizer. So because we are one really close step to transferring all our language or our text to actually numbers and use our machine learning on top of it. So if you have, this is a sample sentence, you need to run it through a tokenizer that will split it to this is a sample, or to be precise, in words. But if you run a traditional tokenizer, if you have I'll go to whatever seaside this year, I'll will be split up to two words, I and LL, and we don't really want that. We want one, or to be translated to I will go if we are transferring to the specific words. With that, we are going to define a custom one that will help with that. And also, one thing that you will definitely see here if you went through the code, we have this cron, and I'll explain the whole code here that we are not going to write right now. When you run a spacey on your text, it will split your sentence to something like this. So if you have the stripped best are hanging on their feet from best, you will have three different outputs for each word. The word itself, the pos, which stands for part of speech, and that is it a verb, is it a noun, adjective, and stuff like that. And the end is lemmatization part of that word. So it's really common to see that we want to strip down each word. So it's the root of the word itself. So for example, D stays as D and stripped because it is past tense. We'll be transferring that to a strip as a present tense. And as you can see, like if we have multiple bats, so you have S and the end lemmatization, or the spacey library will remove that S, and then the bat is the root. Also for verbs that are that don't have like one simple past tense or version per person. I don't know how to say that in English, sorry. But basically, if you have the R and then transfer that verb, it will be B. So it is it's a root verb on its own. Hanging stays for hang, and so on. So actually, why we do this, we are removing a lot of unique words that are not actually unique, but just the same word with different shape and sizes. We don't really want that, because love or loved is still love, because we are still loving that thing, or it still transfers the same knowledge as it was, and that we had a positive sentiment for the thing that we are doing. So if you jump to this scary looking function, it's not really that scary, but let's go through that and define and see what's happening right here. So this function is called custom tokenizer. If you never define the function in Python, it stands with DAF, which stands for define or definition. Then you define the name of that function and then brackets. But if you have some like this, but if you have certain arguments or some inputs to that function that we do right now, you can basically leave them with the names, for example, sentence, English parser, and so on. And then you can use those inside that function. So what is the goal of this function? That we are producing a single sentence. So this function will work on a single sentence only. So if you have like 10,000 different sentences or tweets in our case, you will run this function for 10,000 times. That basically, or in our case, 25,000 times. Okay, so what we are going to do, the first we are going to put a sentence through as the argument. Then we'll do the English parser, and the English parser is something that we defined up a few cells like this here. Then we'll use punctuation that we also defined in that same cell, and stop words. So all English stop words that you use. As you can see, if you put a cursor on top of it, you will see that we have 326 items, and this is basically the content of that. The punctuation, again, it's a string, and you have this this value for it. Cool. So let's see what's happening inside of this. We'll parse that sentence, and this English parser will split our sentence to words that we see right here. So it's the same, the first step to tokenization. And then we'll call this word.lemma, and this is this part of the word, stripped down part. So to have the smaller amount of unique words. Then we will check if the word is not pronoun. That's basically having for our sentiment analysis non-value whatsoever in the data set that we are using. So when you're doing a machine learning project, just a side note here, 80% of the time will be on designing these functions. And training and testing machine learning algorithms will be only, let's say, 20% of the time. Cool. So if it's not, then we'll proceed and say, okay, if we are going to lowercase the word and strip down. Strip means if you have, let's say, car, and then you have this space in front of it or after it and in front of it, then strip down will remove these spaces and leave only a car. So that's basically what the strip does. And lower, if you have car like this, it will move everything to car. That's basically what we are doing inside this step. Okay, so if it's not in stop words, so this will check if this word is not in stop words, and it's not in punctuation, so it's not a dot, exclamation mark, question mark, and so on. Then we will add it to process tokens as a lowercase and stripped version of it. So we'll add to this list that will return. If it is pronoun, then we will do the same step, basically checking whether or not it's a stop word, and then if it's in punctuation, and then finally putting it into the process tokens. This can be further optimized and not used like this, but basically for this case sake, I wrote it like this so we can have a clear view of what's happening inside of it. If you execute this cell, it will be ready. And then you have text processing class. So this class, I won't explain in further details. There are so many nuances and parts of this class, but when I read the documentation of SpaceC algorithm, they basically produced this as a way to process the text. So this is something to help us work with Spatie library. So it's not our code, actually, it's theirs. And finally, we'll jump to the place where we are going to actually convert the raw text into the words, into the numbers, actually. So you have two different versions here, and that's BOW stands for bag of words. And here you have some crazy looking functions that is not seen clearly on my dark theme here, but let's explain. So there are a couple of ways to change the raw word, to change the raw sentence to numbers. One would be bag of words, and that is most common one. Basically, as you can see in the example right here, we have the sentence, it is the best of the best, split down to each of the words that we done in the tokenizer step. And then we will basically check whether or not this word is a present in a document or not, or activated. So because E and N are something that we call stop words, so we are not going to use that. And in this case, a document can be a simple sentence. Or if you are, for example, creating an email spam filter and checking whether or not a certain word is in the whole email, in that case, that email will be a document. So it really depends on what task you are doing with the text. The same goes for this. So one thing that you can do is basically check whether or not a certain word is a present or not, or counting how many times a certain word has been mentioned. So this is not a great example right here, but you can basically check, okay, so looking at the whole text, we've seen that best is repeated 10,501 times. So wherever that best is repeated again, we will just change that with 10,501. That is a way to do it as well. The additional way to do it, and one thing that we're going to do as well, so we are going to use both bag of words and TF-IDF. TF-IDF is more complicated, but better accuracy. TF-IDF is really simple. Don't get scared of this. So it's term frequency and inverse document frequency algorithm. Term frequency, I've already explained, that is a bag of words, and counting how many times a word, let's say best, has been repeated across all tweets that we have. That's term frequency in one case. In this case of TF-IDF, term frequency would be how many times a certain term or the best has been repeated in a single tweet. So our document in our case is a single tweet. And then if we have the best of the best, then best is repeated twice. Okay, so that's basically the term frequency in our case. That would be 2. And then we multiply that by how many times that term frequency or that term has been repeated across all tweets, or in how many tweets has that word has been repeated. So if you have best in, let's say, 1,000 tweets, that's this number, and n would be how many tweets we completely have. So in our data set, we have, let's say, total number of documents, we have 35,000 or 25,000 that in the training set, and then number of documents containing a word best, so that would be this, and we take logarithm of that and multiply with term frequency in a specific tweet. So let's say this would be 2 if we have, this is the best of the best for word best, multiply, by a logarithm of 25,000 divided by, let's say, 10,000 times. That would be this TF-IDF, and we multiply that by our using that in our algorithm, and that's how you change a certain word, in this case best, to a single number which is represented. It does not sound logical to be working, but it actually does work pretty well. There are some other more advanced techniques. This is a pretty old one, but we are not going to explain that right now. Cool. I see that we are 39, so I'll just copy and paste this code so we don't have to write it down. But basically, this code right here defines our both vector and TF-IDF vector. So we are using these two algorithms to define our processing. So first off, count vectorizer and TF-IDF vectorizer does these things that we defined on top of our tokenized sentences. So we defined our tokenizer up here, this one, custom tokenizer, and we'll put a sentence, a raw sentence, through this custom tokenizer, and then we'll run our bow vector and TF-IDF. And that's going to be the output. This n-gram range is not important for now. If we have time at the end, I will explain this, but for now, just leave it as it is. Cool. So this is lambda function. It's a bit advanced for this lesson right now if you never used Python, but just believe me, this works as it should right now. Cool. Now that we defined these two, we never actually called any of this on our data set. So it's time to define the first machine learning algorithm called logistic regression. And this logistic regression is very simple classification algorithm. Classification means that for any input, it will say it is 0 or 1, or 0, 1, or 2. So this logistic regression will help us to determine whether or not a certain vector of numbers from these two vectorizers will contain a positive or negative sentiment. So to do that, I'll again copy and paste my code from the Google Doc that you already seen, and we'll have something like this. So first off, pipeline, it basically defines a set of functionality that we are going to call in an order that we define. So when a new sentence enters, it will go through cleaner, and that is our text cleaner that we defined right here. And then we'll define our vectorizer. So in this case, I used bow vector, but you can use TF-IDF. It doesn't matter, whatever you prefer. And we can test both and see which one works the better. And finally, we'll call the classifier. Right now, we don't have a classifier, so let's write one. Classifier is equal to logistic regression. And that's basically what we are going to do. When you're working with sklearn functionality or libraries, you have this .fit function where you call the training process. So .fit means train. Use these numbers or sentences and then train. So if I execute this, oh, okay, I didn't write correctly. Yeah. So let's run this. It will take a couple of seconds. Okay, cool. If you have this message right here, that means that it is correctly trained. And finally, when you have the trained model, you can actually delete these two for now. We don't need this to explain. You need to model accuracy or to check what is the accuracy of our logistic regression. So we'll call this predict is equal to pipe from here dot predict on X test. And as we explained at the beginning of this this workshop, we use that test set to make sure that we have the model prepared for users that never actually written any, for example, tweets. And then we'll make some predictions. And finally, we'll run this metrics.accuracy score. So accuracy score is nothing more than comparing, okay, it should be 1, but we predict 0 or vice versa. And that's something that we have right here. So this number might sound a bit odd to you. So if you multiply this by 100, you will see that you have 96.17% accuracy. So in 96.17%, you will have the correctly classified your tweets from your users about your brand. So it can be automatically classified as a positive or a negative, and then you can analyze further and say, oh, then we have, let's say, 50% of tweets or even more tweets that are negative for our brand right now. We need to change that we need to, let's say, improve our branding, improve our messaging, or whatever the decision made on top of that. But this model can be used to predict on the real tweets from the real world. We have some questions. Okay, I'm done with this. So with this, I'm ready for questions. Yeah. Okay. So let me tell you. Let me know if you have any questions about this. I'm sure you have a lot, but yeah.
It's really a question, maybe just to thank you for the good explanation and everything. I mean, I didn't have much knowledge about it, but yeah, it was really useful, and thank you for this.
Yeah, thank you. But yeah, I know I try to slow down on certain things, but 45 minutes for this is a bit short. So I do understand if you got a lot of information at once. So sorry about that. If you have any questions about this and you further want to develop this for your company, please let me know and then I can assist you in that via LinkedIn or whatever.
I have a question. How long have you been into this matter, and how long did it take you to master it, let's say?
I don't know if I master it. So master it is quite far-fetched, but I've been in machine learning and AI about 6 years now. So yeah, working with many different companies across the world. Yeah. For mastering it, I would definitely working knowledge. So you can have a working knowledge of this for a junior position in about a year and a half, if you have a good mathematical grasp. If you don't, if you are engaged with mathematics, which most of us were in a school, I would definitely go and prolong that to maybe 2.5 years, depending on how much you like in mathematics. But you can definitely learn the topic in machine learning quite fast after you have a good mathematical background.
Cool. Thank you, Luka.
Okay.
Yeah.
Okay, if there is no more questions, I would like to thank Luka for a lovely presentation, and it was really interesting. It is complex, and I do believe that it needs time to grab that all into your heads and to try it, and then step by step to learn different things and to learn how to apply things that we heard about. Okay, I would like to thank everybody that joined us. I would like to thank you, Luka, for joining us on the Regional Scrum Gathering.